Okay, graph the following inequality. Y is less than or equal to x squared minus 4. Again, anytime you think, why do we keep doing the easy one? Why don't you throw more different examples so we can see some more idiosyncrasies? Because I believe we should do simple examples that we already know very simply. And then when introducing more difficult concepts, they're easier to grasp. And then learning the steps and then just applying them to harder questions. So the first thing we're going to do is we're going to graph this thing with a table of values. Haha, yeah, right. So we're going to do a table of values in our head. 0 squared is 0, minus 4 is negative 4. Or just remember the parabola shifted down 4. And we have a 1 in front of the x squared, so we have a 1 squared is 1 pattern, symmetrical point. 2 squared is 4 pattern, symmetrical point. Ooh, notice I'm using closed dots. Forgot about that. I forgot about the point off to the right. Let's draw a solid line. Because it was greater than or equal to or less than or equal to, but remembering, like down below, it's going to be dotted. So then now, again, we do the same instructions that we did when we did linear equalities in two variables 2 sections ago. We pick a test point like 0, 0, and we substitute it into the equation above for x and y. So putting 0 in for x and y, 0 less than equal to, I'm going to substitute with brackets. And on the left-hand side, 0, the same sign, negative, less than equal to. 0 squared is 0, minus 4 is negative 4. Is 0 less than negative 4? Is 0 to the left of negative 4 in the number line? No. So we're going to put an x. And what does that mean? Well, again, we remembered, if before, in 2 sections ago, if it was wrong, we shade not that side. So if 0, 0 is right in the center at our origin, we shade not that side. So not inside, but on the outside. So those are the exact same English instructions from linear equalities 2 sections ago. Draw the graph with open dots and dotted lines, or closed dots and solid lines, or the curve, or whatever it is. Pick a test point on either side of the line. If it's correct, shade that side. If it's incorrect, shade not that side. Or test the other side and make sure it's correct. Okay, so let's very quickly look at the notes. So I'm going to put a big red box around where we're looking. So in the middle here. Now we're going to be going a little bit faster because we already did these exact same instructions 2 sections ago in 9.1. And we did so much of it in previous chapters of quadratics. So let's say we didn't get any of the information above apart from the graph and the shading. Well, the first thing that we're going to do is we're going to find the equation in vertex form. And if this stuff looks difficult to you, then go back and learn how to find the equation. Then we're going to find the equation y equals x minus 4. We're going to write it off to the right or below. Then we're going to do exactly the same instructions. So we're going to pick a test point like 0, 0. We're going to put it in. We know we're shading not that side, so make an incorrect statement and put the sign that you figured out into the equation you've just figured out off to the left. Reversing the process. Okay, so, look at this. Should I explain another one? No. Look at the top thing. There's an equation. Graph it. How? I don't know. Complete the square. Do whatever you want to. Factor it to find x-intercepts. Complete the square. Do the test point. Decide if you're shading on the inside or the outside. Remember open dots or closed dots. Or if you're given the equation, find the equation the same way we just did above. Go back and learn how to find an equation better or practice it more before you get to this. Do the test point like 0, 0. Remember the idiosyncrasy when you can or cannot do that. Because we're shading that side, check mark. Write down the equation. So given the equation and you have to find the graph, or given the graph and you have to find the equation, just like we talked about in linear 2 sections ago. So again, I understand the little bit of concern about the order. Why did they do lines shading above or below? Then X, where the only answer is the domain. Then they came back to parabolas shading above or below. Odd. No worries. So that's shading above or below parabolas, or finding the equation that represents this thing. When I was at the Sauder School of Business, one of my final exams, my first year, I was upset I didn't take foundations along with pre-calculus because they go way more into this greater than, less than. And with multivariables and so many things being greater than or less than based on how other things are being greater than or less than, very helpful section. Even though it's kind of put in at the end and not really taken too seriously. But when is the rocket ship high enough to get out of outer space? Shade the section, etc. Okay, so that's linear in two variables, linear and quadratic in one variable, and then quadratic in two variables like we did one variable before.